Hey everybody, and welcome to our next video over quadratic characteristics. If you would, take a moment and go ahead and explain all the transformations of the quadratic equation you see on your page. So first off, I take a look at this 2, okay? This 2 is positive, so it opens up. It's also larger than 1, so it's more narrow. I look at this 1 here. This is an x minus a positive 1 because the subtraction sign is a part of the original equation. So that means that this moves to the right 1. And last but not least, this plus 5 means I move up 5 units. Alright, so the x-intercepts of a quadratic are whenever a quadratic crosses the x-axis. So let's say we have a x and y axis. Here we have a coordinate plane. And I would draw a quadratic function, so a parabola. The x-intercepts are wherever the parabola touches the x-axis. So in that case, there are 2 solutions to the quadratic. However, there are several other names. The first of those names is a 0. And the reason we call it a 0 is because at this value, y is 0. We also call them solutions and roots as well. So notice that I could actually call this by any 4 names. I could say, what are the solutions to this parabola? What are the x-intercepts? What are the zeros? What are the roots? You need to be prepared to tell me this answer regardless of what terminology I use. So some vocabulary. First off, axis of symmetry is x equals h. Recall that h was from your vertex. Remember, the vertex is h comma k. So if my vertex is 5 comma 4, then the axis of symmetry will be x equals 5. It's whatever my h value is. The domain of a quadratic equation, remember, domain is all of my possible x values. So all of the possible x values that a parabola or a quadratic can be is all real numbers. You can also write it as this capital R symbol here. Range is all the y values. Now this differs from quadratic to quadratic. You have to look at the picture and say this is the range for this particular quadratic, whereas domain will always be all real numbers. So the y-intercept is where it crosses the y-axis. Ooh, excuse me. And the x-intercept is where it crosses the x-axis. Now the vertex, notice this formula is different than the h comma k we are used to. This is because you will use this only when the quadratic is in standard form. You will use this when it's in vertex form. Okay? Remember that standard form is ax squared plus bx plus c. That's y equals, and the vertex form is y equals a x minus h squared plus k. Alright, so let's take some looks at a couple of examples. This is y equals x squared minus 8x plus 7. First off, what is the domain of this function? I can go forever to the left and forever to the right, so this will be all real numbers. You could use this capital R, or you could write the words all real numbers. Okay, what is the range of this function? Notice that it goes all the way down to the vertex. So I would start by finding the vertex. This equation is in standard form. So I would need to use negative b over 2a to find the vertex. So I have negative as a part of the equation. The b is negative 8 all over 2 times 1. So the x value of my vertex is 4. Well, what is y? All I have to do to find the y coordinate of the vertex is to plug in 4 for x. So 4 squared minus 8 times 4 plus 7 will give me negative 9. So my vertex is the lowest point I can go. This is actually called my minimum. And the lowest y value I can have is the y value of my vertex, -9. So that means I am larger or equal to -9, because I can be any number above -9, I can be -9 itself, and that's it. Now, taking a look at the x-intercepts, we have 1 and 7 is where it crosses, so x is equal to 1 and 7. The axis of symmetry is x equals h. So if h is 4, then my axis of symmetry is x equals 4. And last but not least, the y-intercept. Well, it's a little hard to tell what this is, but remember the y-intercept is where x is 0. So if I plug in 0 here and here, I result in 7. So the y-intercept is y equals 7. Actually, let's do this. There we go. Now, sometimes when we're working problems, the x-intercepts won't look so easy like it did here. So let me show you how I get 1 and 7 without ever looking at the picture. Okay, here I have y equals x squared minus 8x plus 7. What I can actually do is I can factor this. The two numbers that multiply to 7 that add to -8 are -7 and -1. Then what I do is I set this equal to 0. I know that whenever I have an x-intercept, y equals 0. So I can set each parentheses equal to 0. So x minus 7 equals 0, x equals 7. That is one of our x-intercepts. X minus 1 equals 0, x equals 1. That's our other x-intercept. So what I'm doing here is if the picture is not clear, what I can do is I can factor it and say, okay, x minus 7, that has to mean plus 7 is one of my x-intercepts. And we'll talk more about that when we get to solving quadratic equations by factoring. Alright, so let's take a look here. First off, the vertex, let's go ahead and find it. It's -b over 2a. So -8 over 2 times 1 is a positive 4. When I plug in 4 for x here and here, I will result in a -1. Alright, so the domain is always going to be all real numbers. The range is going to be my vertex. So let's see, this is the minimum here because this is as low as it goes. So I'm going to be all y values greater than or equal to the y value in my vertex, -1. The x-intercepts here are going to be 3 and 5. The axis of symmetry is x equals h, and h was 4. Notice that the axis of symmetry is where the parabola gets cut in half. And the y-intercept, if I plug in 0 for x, I'm left with 15. So the y-intercept is x equals 15. Alright, so what I'd like for you to do here is pause and try this problem, x squared minus x minus 6. Alright, so here are the worked out solutions. Notice that your vertex is a decimal. Okay, the vertex is the minimum here, which means that when I do my range, I'm all numbers greater than my minimum of negative 6.25. So the next thing that we need to discuss is intervals of increase and intervals of decrease. If a graph is growing or if the slope is positive, we call this increase. If it's falling or has a negative slope, we call that decrease. So taking a look at the picture, we have the parabola, and it has been cut into two sides, a red side and a blue side. So the question is, which one is increasing and which one is decreasing? Now, we always read from left to right. So what you will do is you will follow along on this blue section. Okay, as I read from left to right, did it rise or did it fall? And the answer is that it fell. So the blue side is going to be my interval of decrease. The red side, when I read from the beginning of the red portion all the way to the end, is that it increases. So this is going to be the side that increases. So the question is how do we show this change? What intervals increase and what intervals decrease? So what we do here is we actually take a look at the vertex. So using the standard form, we can find the vertex, negative b, and b is negative 8, over 2a. So I get a positive 2. So the x value here is 2. So my axis of symmetry, if I don't make a slanted line, I make a straight line, there we go, is x equals 2. So to the left of x equals 2, I'm decreasing, and to the right of x equals 2, I'm increasing. So what I'm doing here is for all numbers less than 2 is decrease. So all x numbers that are less than 2 is decreasing, and all the numbers that are greater than 2 are increasing. Notice it did not put equals 2 on either one. The reason for that is at x equals 0, or x equals 2, the vertex, the slope is 0. And 0 is neither positive nor negative. Alright, so taking a look at this graph, the blue side is falling, so that would be decrease. And the red side is growing, so it would be increase. So the interval of increase is going to be any number, x number, that is greater than 4. And the decrease is going to be any x number that is less than 4, because 4 is our axis of symmetry. Alright, moving on. Okay, again we have an axis of symmetry. This time our axis of symmetry is at x equals 3. Okay, the blue side is decreasing as I read from left to right, and the red side is increasing as I read from left to right. So the interval of increase is all the x numbers that are greater than 3, and the interval of decrease is all the x numbers that are less than 3. So it looks like there's a pattern and it repeats itself. Now, I'm going to throw you a curveball. Excuse me. This is actually a negative quadratic, meaning it faces down. Take a look. We still have an axis of symmetry. And this axis of symmetry is at x equals 4. So let's go ahead and color this one side blue and one side red. Whoops. So if I read from left to right, this blue side is actually increasing while the red side is decreasing. So what that means is the interval of increase is all numbers less than 4, and the interval of decrease is all the x values that are greater than 4. So it flip-flops here than what we've seen in the last 3 patterns, because this happens to be a negative quadratic. So you got to be very careful about looking to see which interval of increase and which interval of decrease. You can't just say, oh, I think I know this. You actually need to look at the graph of the picture. Alright, well that's it for today on the characteristics of quadratics.